In physics, moment is a combination of a physical quantity and a distance. Moments are usually defined with respect to a fixed reference point or axis. They deal with physical quantities as measured at some distance from that reference point or axis. For example, a moment of force is the product of a force and its distance from an axis, which causes rotation about that axis. In principle, any physical quantity can be combined with a distance to produce a moment. Commonly used quantities include forces, masses, and electric charge distributions. Elaboration. In its most simple and basic form, a moment is the product of the distance to some point, raised to some power, multiplied by some physical quantity such as the force, charge, etc., at that point. Whereas the physical quantity such as a force applied at a point, or a point charge, or a point mass, etc. If the quantity is not concentrated solely at a single point, the moment is the integral of that quantity's density over space. Whereas the distribution of the density of charge, mass, or whatever quantity is being considered. More complex forms take into account the angular relationships between the distance and the physical quantity. But the above equations capture the essential feature of a moment, namely the existence of an underlying or equivalent term. This implies that there are multiple moments and that the moment generally depends on the reference point from which the distance is measured. Although for certain moments this dependence vanishes and the moment becomes independent of the reference point. Each value of n corresponds to a different moment. The first moment corresponds to n equals 1, the second moment to n equals 2, etc. The zeroth moment is sometimes called the monopole moment, the first moment is sometimes called the dipole moment, and the second moment is sometimes called the quadrupole moment, especially in the context of electric charge distributions. Examples: the moment of force, or torque, is a first moment, or, more generally, the electric dipole moment is also a first moment. For two opposite point charges or for a distributed charge with charge density, the moment of inertia is a second moment. For a point mass, for a collection of point masses, or for an object with mass distribution. Multipole moments. Assuming a density function that is finite and localized to a particular region. Outside that region or 1R potential may be expressed as a series of spherical harmonics. The coefficients are known as multipole moments, and take the form, where expressed in spherical coordinates as a variable of integration. A more complete treatment may be found in pages describing multipole expansion or spherical multipole moments. When represents an electric charge density, the R, in a sense, projections of the moments of electric charge, is the monopole moment, the projections of the dipole moment, the projections of the quadrupole moment, etc. Applications of multipole moments. The multipole expansion applies to 1R scalar potentials, examples of which include the electric potential and the gravitational potential. For these potentials, the expression can be used to approximate the strength of a field produced by a localized distribution of charges by calculating the first few moments. For sufficiently large R, a reasonable approximation can be obtained from just the monopole and dipole moments. Higher fidelity can be achieved by calculating higher-order moments. Extensions of the technique can be used to calculate interaction energies and intermolecular forces. The technique can also be used to determine the properties of an unknown distribution. Measurements pertaining to multipole moments may be taken and used to infer properties of the underlying distribution. This technique applies to small objects such as molecules, but has also been applied to the universe itself, being for example the technique employed by the WMAP and Planck experiments to analyze the cosmic microwave background radiation. History. The concept of moment in physics is derived from the mathematical concept of moments. The principle of moments is derived from Archimedes' discovery of the operating principle of the lever. In the lever, one applies a force, in his day most often human muscle, to an arm, a beam of some sort. Archimedes noted that the amount of force applied to the object, the moment of force, is defined as m equals rf, where f is the applied force, and r is the distance from the applied force to object. However, historical evolution of the term moment and its use in different branches of science, such as mathematics, physics and engineering, is unclear. Federico Comandino, in 1565, translated into Latin from Archimedes, "The center of gravity of each solid figure is that point within it, about which on all sides parts of equal moment stand." This was apparently the first use of the word moment in the sense which we now know it, a moment about a center of rotation. The word moment was first used in mechanics in its now rather old-fashioned sense of importance, or consequence, and the moment of a force about an axis meant the importance of the force with respect to its power to generate in matter rotation about the axis. But the word moment has also come to be used by analogy in a purely technical sense, in such expressions as the moment of a mass about an axis, or the moment of an area with respect to a plane, which require definition in each case. In those instances there is not always any corresponding physical idea, and such phrases stand, both historically and scientifically, on a different footing. A